Hey guys, today we're having a look at Assessment 10, which covers simplifying ratios, equivalent ratios, probability, expectation, and metric units of area. Now this is not a lesson, this is a practice test. So if you're looking for lessons on these topics, have a look at the description box down below and I'll link some there for you. If this is your first time through this practice test, make sure you hit pause and try the questions for yourself first, and we will take them up at the end. Question 1 is a probability and expectations question. Hit pause if you want to try it. Question 2 is also a probability and expectation question. Question 3 is an expectation question. Question 4 is a ratio and simplifying ratio question. Question 5 is a ratio and equivalent ratio question. Question 6 asks you to convert units of area. Question 7, these are equivalent ratio questions. And question 8 is also an equivalent ratios question. Now that you've had a chance to go through those questions for yourself, let's start taking them up. If you found that you struggled with this and you would rather go through some lessons first, have a look in the description box below for those links. Okay, so for this first question, I hope you read it carefully. We were asked what the probability is of the spinner not landing on A. That is A with a little line up here. That's not A. So while the probability that the spinner lands on A is 2 out of 5, a probability is always a fraction, so not just 2, but 2 over 5. The probability that it doesn't land on A is all of the other possible outcomes. There are 5 equal-sized sectors on here, and 3 of them are not A. So our probability that we don't land on an A is 3/5, or you could write as a decimal 0.6. The probability of the spinner landing on a B or a C, they're both equally likely probabilities, and they are mutually exclusive. If it lands on a B, it's not at the same time on a C, and vice versa. So to find the probability that it's one or the other, we can just add the two probabilities together. Probability of B or C is equal to the probability that it's B plus the probability that it's C. And in both cases, the probability is 1/5. So the probability that it's B or C is 2/5. Now I realize most of you could probably jump directly to that answer, but it's really good to have that theory in mind for when it's a little bit more difficult. If it's one or the other and they're mutually exclusive, you can add their probabilities together. So 2/5, or as a decimal, that's 0.4. Question C, do you have an equal chance of landing on either a B or an E? Well, there is one sector, which is a B, and there's one equal-sized sector, which is an E. So yes, it would be equally likely. But that's not the case for every letter. For example, A, because there's 2 sectors, it's more likely to land on A than it is on any of the other letters. Question D, if the spinner is spun 80 times, how many times do you expect to spin a C? Expectation is some number of times, as you can see from our answer line. So it's not going to be a fraction or a decimal. It is some whole number of times out of the 80. Now I wouldn't expect to get a C all the time, but I would expect to get it at least once. I would expect to get a C some fraction of the time. And that fraction happens to be the same as the probability of getting a C. I expect to get a C 1/5 of the time, because 1/5 of the spinner is C. So 1/5 of the number of spins should be a C. 1/5 of 80, that's 16 times. Out of 80 spins, I expect 16 C's. Right, question 2 is also probability and expectations. Here we're talking about a magician's coin, and I'm pointing out for you here that I think it's fake. I think there's something wrong here. If I see the magician flip his coin 20 times and it only lands on tails 3 times, what would you say is the experimental probability of flipping the heads on this magician's coin? Experimental probability is not the same thing as theoretical probability, because I already have my suspicions that although this coin has 2 sides, they are not equally likely outcomes. So experimental probability, we have to do an experiment. We conduct the experiment several times and we see how many positive outcomes we get. So the probability of getting a heads based on this experiment is the number of heads that we get in the whole experiment over the number of flips we've done in the whole experiment. Now I hope you read this carefully. The magician flips his coin 20 times and it lands on tails 3 times. So the number of heads must be all of the other times. There are 20 flips, 3 of them were tails, 20 minus 3 is 17 out of 20. So the probability of heads based on our experiment is 17 over 20, or as a decimal that's 0.85. Now, how many heads would you expect in a 20 flips of a normal, fair coin? So think about what the theoretical probability of flipping a heads on a coin is. There are 2 sides, one's heads, one's tails, so the probability of flipping a heads is 1/2. So I would expect to get 1/2 of those coin flips turn up heads. The expectation is always some fraction of the total number of tries, and this fraction is 1/2. So 1/2 of 20, that's 10. I would expect 10 heads on a normal fair coin. So am I right to suspect that there might be something special or wrong with this magician's coin? There's quite a big difference between getting 10 heads and getting 17 heads. So yes, I think that there is reason to suspect something's going on here. Question 3, expectation again, but it's done in a slightly different way. If I roll one fair die and I see what number comes up, doesn't matter what that number it is, that number is written down. This is where my experiment begins. I start rolling another die, and any number could come up. I'm going to keep rolling that die until it matches the number with the first die. So how many rolls do I expect to need before I manage to match the number on the second die with the first die? Now it does not matter what number I rolled on the first die, but on the second die, I have 6 possible outcomes, and one of those outcomes will match the first die. The expected number of matches is the probability of matches multiplied by the number of rolls. Now we're not trying to find the expected number of matches. I'm trying to find out how many rolls it would take to get one match. But I'll use this formula to rearrange it to find the number of rolls. I know I want one match, so how many rolls would it take for me to expect one match? Let's substitute into the formula. If I want one match, and I know the probability of matching the rolls is 1 out of 6, that multiplied by the number of rolls should give me an answer of 1. So let's rearrange this then to find the number of rolls. To get rid of the 1/6, I'll send it to the other side. It's multiplying on the right-hand side, so I'll divide by 1/6 on the left-hand side. Now you can calculate that directly, but I'm hoping we can play with our mental maths here and remember that to divide by a fraction, we flip it and multiply. So we're going to do 1 times 6 over 1, which is just 1 times 6. It should take us 6 rolls. I would expect to get one match in 6 rolls. It might happen that we get a match earlier. It might happen that we get a match later. But you know when you lose your phone and you're looking everywhere for it and it's always in the last place you think of? Well, you would kind of expect to look in all of the possible places until you find your phone. If you find it earlier, you got lucky. Okay, question 4. What is the ratio of stars to triangles? So that's just asking you to count all of the stars and all of the triangles. I'm counting them here. I've got 2 stars and 1, 2, 3, 4, 5, 6 triangles. Times that by the number of rows. There's 1, 2, 3, 4, 5, 6, 7, 8 rows. So 2 times 8 is 16 and 6 times 8 is 48. That's my ratio of stars to triangles. Now we can simplify this ratio, but I hope you didn't in the first step because you can see that the second question is asking us to do that. To simplify this ratio, we need to divide both sides by the highest common factor. I know you can divide both sides by 2, but you can divide by something bigger than that. You could divide them both by 4 as well, but even bigger than that, you can divide both sides by 16. So the simplified ratio is actually 1 to 3. I saw a lot of 2 to 6s there, probably because you just looked at the first row. But I can still divide 2 by 2, and I can divide 6 by 2. So our simplified ratio, 1 to 3. Our next question is very similar. Study the pattern and write a simplified ratio for the hearts to the total number of shapes shown. I hope you read that carefully, the total number of shapes shown. So, looking at how many hearts there are there, I see that there's 1 heart in each row, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 circles in each row. But I'm not going to say that this is a 1 to 9 ratio. First, let's write this in words. Hearts to total. There is 1 heart in each row, but in total, there are 10 shapes in each row. So the simplified ratio will be 1 to 10. Now you could have said it was 5 to 50 because there are 5 hearts and there are 50 shapes in total, but the simplified ratio is 1 to 10. Both 5 and 50 divide by 5. Now if we continued this pattern to show 450 shapes all together, how many hearts would there be? So we're continuing this pattern until the total is 450. What do I have to multiply 10 by to get 450? Because I'll do the same thing to the 1. 10 times 45 gives us the 450. So we do 1 times 45, and that's how many hearts we'll have. Next, metric units of area. I've given you the area of a rectangle in meters squared, and I need you to work it out in centimeters squared. You should know that to convert from meters to centimeters, we times by 100. But be careful because we've been over this. If you need to have a look at the lesson down below, please do. To multiply, to convert from meters squared to centimeters squared, we don't just multiply by 100, we multiply by 100 squared. That is multiplying by 100. And then multiplying by 100 again, which, be careful, is not 200, it's 10,000. When we multiply by 100, we put 2 zeros on. We multiply by 100 again, we put 2 more zeros on. So I've got 4 zeros here altogether. Keep that in mind when you're multiplying this out. I'm not going to just put 4 zeros on the end of this number, however. I'm moving all of the place values up 4 places. That involves moving this decimal 1 place, and then moving it 3 more places to be 4 altogether puts 3 zeros after that 8. So it's 48,000 centimeters squared. Now keep that process in mind when we convert 4.8 meters squared to millimeters squared. Have a think about that before I go through it. To convert from meters to millimeters, you have to remember that we multiply by 1,000. So to convert from meters squared to millimeters squared, we have to multiply by 1,000 squared. Again, be careful that's not 2,000. That's 1,000 multiplied by another 1,000. So we'll put on 3 zeros and put on 3 more zeros. That's 1,000,000. So we're going to multiply 4.8 by 1,000,000. And just like we did before, that does not mean we're putting 6 zeros at the end of this number. It means we're moving all of the place values up 6 places. So we're moving this decimal 1 place to after that 8, and I'm missing another 5 more places to go. So I need 5 zeros after that 8. That's going to be 4,800,000 millimeters squared. Next question is an equivalent ratios question again. You're told the ratio of goldfish to blackfish in a pond is 8 to 3. It would help if I actually wrote that in ratio format. So I'll write that in words, gold to black, so we can be clear about which number is which, 8 to 3. And now I want to work out the number of blackfish there are if there are actually 72 goldfish. So on the gold side, we want 72. On the black side, we need to think, how did I get from 8 to 72? What did I need to multiply by? I multiplied by 9. 8 times 9 gives me 72. If you struggle to find that number, try going the other way. 72 divided by 8 is 9. And then double check your answer. 8 times 9 is 72. So both sides were multiplied by 9. Let's multiply the black side by 9. That gives us 27. So if there's 72 goldfish, there would be 27 blackfish. Now, work out the number of goldfish there would be if there were 18 blackfish. So again, I'm going to write the original ratio, just in case I made a mistake before. So the original ratio was gold to black is 8 to 3. And we're told now that there are 18 blackfish. So I put the 18 on the black side. And now I have to think, what did I multiply 3 by to get 18? If you're having trouble thinking about it, try going the opposite way. What's 18 divided by 3? It's 6. So try that again. Is 3 times 6 18? Yes, it is. So we'll do 8 times 6 as well. 8 times 6 is 48. So there would be 48 goldfish if there were 18 blackfish, maintaining that original ratio of 8 goldfish for every 3 blackfish. Last question, it's an equivalent ratio question, and a lot of people ask me if each of these ratios have to be equivalent to the one above or to the original. If they are all equivalent, they are all equivalent to each other. Doesn't matter whether you're comparing with A and B or B and C, they are all equivalent. So let's start with A. I can see that to go from 4 to 12 to something to 3, I must have divided 12 by something. 12 divided by 4 gives me 3. So I'll do 4 divided by 4 as well, and that gives me 1. 1 to 3. Now that ratio is actually the simplified ratio. I can't divide both sides of the ratio by any common factor without getting into decimals. So that ratio might be the best ratio to use to compare the other ratios with. For example, for B, I can quite easily go from a 1 to 3 ratio to a 15 to something ratio. Clearly, to get from 1 to 15, I need to multiply by 15. So I'll do 3 times 15 as well, and that gives me 45. Now again, for C, it might be difficult for me to get from 45 to 60. But if I go to that equivalent simplified ratio that I had in A, and then I think, what do I need to do to this ratio, 1 to 3, to get the ratio something to 60? What did I multiply 3 by to get 60? By 20. 3 times 20 makes 60, so 1 times 20 makes 20. And finally, for D, I need a 1 to something ratio. I've already got a 1 to something ratio. It's the same one as I had in A. Now I hope that you found this practice test helpful. And if you're still struggling, please leave me a comment so I can clarify any doubts that you've got. If you enjoyed this, please like and subscribe so I can provide more content like this in future. Till next time, keep practicing and I'll see you soon.